Hi Barbie girl, hi Nidhi, hi Akriti, hi Shama, hi Harshit, Sharvin, hi Abhirami, hello Saurav, welcome aboard. So guys, if you want to know more about me, definitely you can follow me on my Instagram handle. And before we begin, do not forget to hit the like button to show your love, to show your support. That's all that we ask. Just a simple like button out there. Yes, and if you're new to this channel, this is an English channel. So if you want all the sessions in English, this is the channel that you should subscribe to. Go ahead, hit the subscribe button. All the session PDFs, important announcement, timetable, etc. will be uploaded on our Telegram channel. So the link for joining the Telegram channel is there in the description box below. Okay, having said that, this is the timetable for the week in case some of you would have missed it. All right. So I had covered the first lecture of units and dimensions on Tuesday. Usually my lectures are at 7:30. So you can watch that lecture in case you have missed it. So today we are on the second lecture of significant figures and errors. That's what we are going to do today. And tomorrow is a very special session. Are you guys excited? How many of you are stressed? How many of you want that relaxation to happen? So guys, I have planned it for you. Now, if you want me to conduct more such sessions, strategy sessions, relaxation sessions, fun sessions, career guidance sessions, and so many other things, you want expert talks, you want, a whole, you want an all-round kind of a development, then please let me know. And do not forget to hit the like button out there, share it with your friends, comment after every video. That gives us the strength, that shows us your support, that shows us your inclination towards all kind of topics. So please let us know in the comments after the video, or by hitting the like button out there. Now, last lecture I had given some homework and some of you have attempted it and some of you have also posted the answers. I can just show you who and all were there. Yep, let's see where is our video. Yeah, there it is. There we have Units and Dimensions lecture 1. In case you have missed it, please go ahead and check it out later on. Okay, and there we have a lot of people. Shri Varsha, very good. Asif Khan, very good. Thank you. Yes, Asif, I'll be there with you for JEE Mains as well as advanced. Don't worry. Rashmi, thank you so much. Harshil, Divyansh, Sujata, then Barbie girl, then VJ the DJ, Gaurav, very good. Very good, Ganesh, very good, Shivani. Very good, Ravi. Ravi, yes, you can follow me for NEET 2021 also. Mohit, very good. Excelente, Sanya, Ewan, Aditya, and Selva Kumari, Karthik, Stravanti, and we have Enchanted Guy, and we have, yes, Bharti Singh, Shreyas Kapri, Gautam, Talishka, look at that, Shreya Pandey, Mahiraj, Bharti Singh, Ruth Taparna, Sharvin. Thank you so much, guys. Vedashri and Shreya Kumari. Excellent day. You guys have answered it, and many of your answers are correct. Let me tell you that. That's very good. Congratulations. Good. A big round of applause for all of you. Hello, Semilin Dongel. Hello, everyone. Hello, Akriti. Hello, Harshil, Mayuri. Welcome aboard. So, guys, remember, we need to make sure that you are on the right track. We need to make sure that you guys are, on the correct page right from the beginning, right from books, right from the sessions, right from the concepts, right from the problems that you're solving. So guess what you need for cracking the JEE examination in 2023. See, for cracking the examination after 2 years, you need to start working on the right track right from now. Your preparation has already started. You're already in 11th standard. Make your mindset. So get over 10th standard now. Stop worrying about your 10th standard marks and the college and all those things. Don't worry about it. Start your preparation now. Follow our lectures regularly. What you need for cracking the JEE examination 2023, you need only few ingredients. All right, from the start. One is the correct set of lectures, the sessions from obviously really good teachers in your preferred language, be it English or Hindi. Next thing that you need is assignments and problem solving material after every session and after every chapter. That's what you need. Proper books, proper set of problems and assignments, dedicated set of assignments after every session. Number 3, you need tests, mock tests and analysis reports after every chapter or after 3 to 4 weeks, regular basis, so that you get into the mood. Number 4, that you need is proper doubt solving, proper guidance and mentoring. All these are essential ingredients. Apart from that, I feel you should sit at home. Do not waste your time in travel, and do not waste your time, going to a regular offline coaching where half the things are not prepared, half the things are not offered, and you waste your time, plus you put yourself at risk. There is a health risk of getting COVID and all that. So we have started the regular long-term batches at Vedantu under the pro subscription, where you are going to not only get your regular long-term batches, but also you are going to get KVPY preparation, Olympiad preparation and boards preparation, and that too in your preferred language, English or Hindi. And teachers like me, Shimon sir, Wasim sir, and many other master teachers who might not be even on YouTube are teaching in the pro subscription, as well as the micro courses that we are offering you. So guys, I would request you, because all the ranks that you see around, the amazing ranks, like 1 in 2 Vedantu student has already qualified for JEE Advanced, is only possible because of this team, because of the system, because of our methods. So all the details are there in the description box. You can check out the pro subscription model, and you can definitely subscribe to one of these subscriptions, either light, classic or plus. I'll tell you what this is towards the end. You can use the coupon code SHHPRO and you can avail maximum discount of 10%. That's a good deal. Okay, so let's get going to what is basically significant figures, and let's start talking about rounding of numbers. Hi Pranav Rana, good evening. Hello Surya, Felicities. Hello Prakash Yadav, welcome aboard. So let's see, how do we exactly round off numbers? Now some of you might have some idea, or back in school you would be rounding off numbers just by your guess or just by your intuition or your gut feeling. But understand, that's not what you're supposed to do in JEE Physics. No, that's not how you do it. Now there are simple rules. I'm going to give you rules. We're going to solve problems. So follow me carefully. Make sure your pen and your rough notebook is outside so that you can solve problems, make notes along with me. Now the first rule is that, see guys, if I tell you you have to round off 25 or a number close to 25, then what you do? Let's say you have a number like 27, you will obviously round it off to 30. And if you have a number like 23, 24, you will round it off to 20. So unless and until it is between. What to do when it is in between, I'll come to that. But if there is a number which is more than 25, you will round it off to 30. And if it is below 25, you will round it off to 20. That's how the intuition says and the gut feeling says. That's exactly your first rule. If the last digit is less than 5, then drop it. For example, 23. If the last digit, what is that last digit? 3. Is it less than 5? Yes. Forget it. So when you forget 23, 3 digit, what is remaining? Only 2. So 20, that's it. That's what is remaining. Understand that. That's how you can round it off. Okay. And if the last digit is more than 5, then increase the previous one by 1. So if you have a number like 27, is 7 more than 5? Yes. So increase the previous digit by 1. So instead of 27, make it 30. That's it. I hope this is clear. Everyone, let's do this rule once more. For example, I have 7.58 and I want to round it off to 1 decimal digit. Now check the last digit. Is the last digit 8? Yes. Is it less than 5 or more than 5? It's more than 5. So then increase the preceding digit by 1 and drop off the remaining. So this will be nothing but 7.6. So that's how you round it off. I hope this is clear. I'll show you one more example. Let's say we have 43. Okay, 18.43. I want to round it off to 1 decimal digit. So check the last digit. This is the last digit. Is it less than 5? Yes. Then just drop it. So this will be basically 18.4. As simple as that. Is everybody understanding this? Is this clear? Is this crystal clear? If it is clear, let me know by writing clear-o, understood-o. Yes, please let me know. Please let me know by writing it down. Beautiful. All of you have started answering. Excellent, Neha, Prakash, Jaivan, Shweta S. Very good, Aishwarya, Punit. Excellent, Ritu. Excellent, Abhijit. Very good, Chinmay. Very good, Prakash. Excellent, Yalini. Very good, very good. So this is how you do it. Now the second rule. Let's go to the second rule. Now the second rule is when you're exactly in the middle. That is 0.5. Now whenever that 5 comes, that's the problem. You don't know whether to go to this side or that side. Now the rule says, it's very simple. If the previous digit is even, then don't worry, just drop the last digit. If the previous digit is even, then don't worry about the last digit, just forget it. Okay? And if the previous digit is odd, then increase the previous digit by 1 and then drop it. I'll tell you what it means. Example. Okay, let's see what that means. So first of all, just imagine this, guys. Oops, I didn't want to go to the problem. 1 second. Yeah. So imagine this. Yeah. So imagine I have 17.65. Okay, I have 17.65. Now the last digit is exactly equal to 5. Okay, the last digit is exactly equal to 5. I want to round it off to 1 decimal digit. Now check the preceding digit. The preceding means the previous one. What is it? It is even. Oh, 6 is an even number, so then just forget the last digit. So this will be equal to 17.6. As simple as that. I will give you one more example. Imagine if it was 17.75. Now check the last digit. What is the last digit, guys? The last digit is 5. Okay, so the last digit is 5. Then what you do? Look at the preceding digit. What is the preceding digit? It's an odd number. It's an odd number. So what will you do? Increase that previous digit by 1. Increase it by 1. Make it even. So this will be 17.8. Basically, whenever it is odd, try to make it even. Whenever it is odd, make it even. And if it is even, keep it even. So if it is even, keep it even. If it is odd, then make it even. By making 75 is closest. See, 75 is closer to 80 also and 70 also equally. But always try to make it even. So make it 17.8. I hope this is clear. Yes. So which days are my nurture lectures for class 11th? Varun, it's not going to be same every week, but you know, usually Tuesdays, Fridays, those are my days. Okay, but it can change, so that's why I'll post it on the Telegram channel. So it's very important, guys, you join the Telegram channel, which is there, the link for which is posted in the description box. So you'll get the exact schedule out there. Okay, so please do that. Okay, very good. So let's do some questions. Let's see how many of you can answer this really quick. I'm waiting. All my warriors, please answer this really quick. Round off 14.56 to 1 decimal point. Come on, all my warriors, all my minions, come on, do that. Thank you, Clay Tsunami, so much. Come on, guys. Let me know what's the correct answer for this. Come on, guys. Come on. Figure it out. What is the rounding off of 14.56 to 1 decimal point? Come on. Think. And guys, if you still have doubts, please let me know in the comment section after the video. If you have checked any of my previous videos, I always reply to all your comments whenever you ask some doubt or a query. So please post it in the comment section, or you can also contact me on my Instagram handle, which is Shreyas_Vedantu. Okay, a lot of you are saying 14.6. Very few people said 14.5. Okay, so guys, yes, the correct answer is 14.6. Come on, think about it. Come on, guys. The last digit is 6, and this number 6 is already more than 5. If it's already more than 5, then what will you do? 56 is closer to 60. So make it 60. So anyways, you have to forget that 0 in the last. So obviously the answer will be 14.6. So understand this previous digit, you have to make, you have to add 1 to it. Only then you can round it off. Yes, that's the rule. That's the rule. Okay, next 1.45 to single decimal digit. Let's see how many of you can do that. Come on, very good, all my warriors. Very good, Gaurav. Very good, Sashishmita. Very good, Prakash. Very good, Shyam. Very good, Samuel. Very good, Neha. Excellent, Ashish. Very good, very good. Come on, Vijay Kumar. Yes, correct. Come on, round this off. 1.45 to single decimal digit. Hi, Chiranjeevi Sujay. Good evening. Join in quickly. You have missed a little bit. You can watch the replay of the missed part later on. Join in, even if you're joining in late, it's okay. Do not forget to hit the subscribe button so that you do not miss the next classes, and hit the bell icon so that you do not miss the notification for the next video. Okay, come on, let's see. 14.4? Yes, beautiful. Let's see, the correct answer is actually 14.4, and the reason for that, sorry, 1.4, my bad, 1.4, because when you have this digit 5, then you should always look at the previous number. The previous number is even. When it is even, then just forget that. Just forget that. So it will be just 1.4. Correcto. Beautiful, 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 guys. You have understood how to round off numbers. Beautiful. Let's go to the next part. Now that is significant figures. So now that you have a fair idea of rounding off, very good. Now let's go to significant figures. And if you're loving this video, do not forget to smash that like button down there. Yes, show your support by smashing that like button in case you have forgotten to do that. Now, significant figures is nothing but the set of important digits in any value. It plays an important role not just in physics but also in chemistry. It tells you the set of important numbers, significant, which are important, which have some meaning attached to it. Some digits are meaningless, some digits have some sense or some meaning to it. Before we go ahead, you should know the terminologies. Write it down in your notebook. Although you will get the notes in the Telegram channel, still, please write this down. See, whatever comes before, these are before a number, like non-zero numbers like this one, these zeros are called as the leading zeros. They lead. This is the trailing, the ones in the end. These are called as the trailing zeros. Okay, the ones in between, they are called as the in-between zeros. So you should know these three things. Obviously, 5, 8 and 3 are non-zero digits. The zeros before are called as the leading zeros. The zeros after are called as the trailing zeros. And the ones in between are called as the in-between zeros. Just these are the three things that you should know. Harshini, I come daily, but the 11th standard classes for now are going to be there at least twice or thrice a week, and slowly will increase the frequency also. Right now I'm handling, just imagine guys, 2021 batch, 2022 batch, 2023 batch, plus the strategy sessions, plus my regular classes. So I hope you understand this is just a temporary phenomena till the 2021 students, pass out. We need to take sessions for them also. So after that, we'll slowly increase the number of sessions. Don't worry. Okay. So for now, just understand whatever we are trying to say, and don't worry, we are not going slow. We are exactly at the right pace. Okay. Now, there are 4 rules that I'm going to give you. Hi Abhishek Mitran, welcome aboard. Yes, there are 4 rules that I'm going to give you. First rule, chalo, write it down. Every non-zero digit is in a reported measurement is assumed to be significant. Every non-zero digit. Example, say, I have 758. How many non-zero digits are there? 3. How many significant numbers are there? How many significant digits are there? Come on, answer in the chat box. Come on, think about it. How many significant digits are there in this? 1, 2, 3. So 3. That's the answer. Next, if I write 527.68, how many significant digits are there? Just count the non-zero numbers. 1, 2, 3, 4, 5. So the number of significant digits are 5. I hope this is clear. Yes. Thank you, Harshini Perla, so much. Yes, very good, very good. Yes, this has 5. The previous one had 3. Beautiful. Now let's see whether you can get this. Find the number of significant figures in 27.6. Come on, answer both of them together. And find the number of significant figures in 1.928. Come on guys, let's see how many of you can answer both of them together. Put a comma in your answer. First and second answers, both. I want both of them in your chat box. Come on, put both the answers in the chat box. Why do we need significant digits, Kushali? The reason is because there are certain digits which have no sense or they have no meaning, they are of no importance. So you should know how to round off the numbers to a particular set of digits. You should see, you can write as many digits as you want, but they are meaningless, they are senseless. So when you add, subtract, multiply or do any operation, in any company, in any engineering operation, you should know how many digits you should write, how many digits are not important and important. That's why we study significant figures. Okay, 3 and 4. Well, guys, 1, 2, 3. Yes, I can count 3 digits out here. So 1, 2, and 3. So 3 is the answer. Here 1, 2, 3, 4. I can just see 4, guys. I can just see 4. Some of you had said 5, I don't know why. So 3 and 4, that's the answer. Yes, 3 and 4. Beautiful. Second rule. Let's go to the second rule. Zeros before, zeros appearing between non-zero digits are significant. Zeros appearing, remember the 3 kinds of zeros I was telling you? The before, the in between, and the trailing ones. These are the in between zeros. They are significant. For example, 705. How many significant digits it has? 1, 2 and 3. Understand? So 3. This is important. All 3 are important. Similarly, 1.087. This 0 is important. So 1, 2, 3, 4. This has 4 significant digits. Similarly, 72.0807. Alright, count the number of significant digits. 1, 2, 3, 4, 5, 6. So this has 6 significant digits. So zeros in between are important. You cannot ignore it. That's the rule. Yes, I hope this is clear. Everybody has understood this. Beautiful. Let's see the problems on this. Find the number of significant figures in this number and find the number of significant figures in this number. Answer both of them together by putting a comma in the chat box. Let's see how many of you can get this. Sri Ram Reddy, I love physics and I love teaching and I love you all. That's why I'm here. You don't want me to be here, then I don't know. Then you will not get good teachers. Okay, that will be your loss. Okay, come on. Come on, come on, come on. All my warriors, beautiful. Think about it. How many significant figures in this number? How many significant numbers in this one? No, Samuel, I don't want you to leave. I don't want you to leave. I want you to leave successfully. Yes, I want you to pass out successfully. Beautiful. Some of you are saying 4, 5. Some of you said 5, 5. Okay. Some of you said 4, 6 also. Okay. So count, guys. 1, 2, 3, 4. So 4 numbers. That's it. And here 1, 2, 3, 4, 5. So 5 significant digits. So 4 and 5. Beautiful. Oh, amazing. Give a pat on your back, warriors. Beautiful. You guys are getting it. Now the third rule. What's the third rule? Leftmost zeros, that is, the one which are leading, in front of the non-zero digits are not significant. And it makes sense. Just think about it. 007. Whose number it is? Bond. Right? James Bond. My name is Bond. James Bond. Okay. So, is this 0 significant? Nah. Only Bond can think of these zeros as significant. But you are no James Bond. So, these zeros are not significant. Keep this in mind. Similarly, okay, I hope this is clear. Yes? Similarly, 72 into 10 to the power, okay, sorry, not 72 into 10 to the power, my bad, 0.008. How many significant digits? Only 1. This has only 1. This also has only 1. This 0.008 can be written down as 8 into 10 to the power minus 3. Correct? Both of them have only 1 significant digit. Understand that. I hope this is clear. So, all the zeros before the non-zero digits are not significant. Ignore that. So, 8 into 10 to the power minus 3, 1 significant digit. 0.008, only 1 significant digit. These zeros are not important because you can write 0.008 as this. So, understand that. Yep, beautiful. Okay, Captain, I want to count the number of significant digits in my phone number. Oh, I have... Okay. Everybody knows that. Okay, chalo. Let's do this. Find the number of significant figures in this number and this number. Come on, let's see how many of you can do that. 10 to the power anything is neglected. Yes, Sashmita, correcto. Beautiful. Excellent. Come on, think. Oh, thank you, Ajitesh Joshi. Thank you so much. Namaste, Rajaramar. Welcome aboard. Come on, both the answers separated by a comma in the chat box. Let's see how many of you can get it correct. Count the number of significant figures in this and this. Come on, figure it out. Come on. Rashi, Sabu, thank you for all the love. Yes, come on. 2, 3, okay. Yes, these zeros are useless. Don't waste your time. This has only 2 digits. Beautiful. These are the only 2 numbers which are significant. So 2 And over here, do not forget this 0 is significant because it is in between. So 1, 2 and 3. So 3 significant digits. Beautiful. This 0 is significant. The previous 0 is not significant. Beautiful, guys. Now the fourth rule. Beautiful. Excellent. Give yourself a pat at the back. Beautiful. Fourth rule. What's the fourth rule? Zeros at the end of a number. 0 when it is at the end on that side. Then there is a special rule. Be careful about this. A lot of people get confused. It is significant only if they are on the right side of a decimal point. What does it mean? Only if they are on the right side of the decimal point. Means, look at this. 780. This 0 is on the right side. It's on this side. But this 0 is not significant. No, you should not count it because it's not after the decimal point. So here only 2 significant digits. That's it. But if I wrote it as 78.0, then it has 3 significant digits. Yes, it has 3 significant digits. Understand that. Yep. Understand that. Similarly, see guys, this number is nothing but 78 into 10 to the power 1. Only 2 digits are there which are significant. You might be wondering, sir, why is this 0 significant? You'll be wondering, sir, what about this 45.00? How many significant digits are there? 1, 2, 3, 4. Yes, 4 significant digits are there. You'll be like, sir, why is this 0 important? Reason is, when you write it after the decimal, if you are writing that 0.00, that means you are sure about it. You know that number is actually accurate till this point. That's why you are writing that 0.00. You are not mental or you are not crackpot to actually put the 00s. You are sure about that reading till the second decimal. That's why it is significant. Understand that. If you are not sure about it, then you would have just written 45. Then I don't know, maybe it is 45.01, maybe it is 45 point, I don't know, maybe 23. Maybe you just rounded it off to 45. Who knows? So then you will not be sure of that. So when you just write 45, it has 2 significant digits, but you actually put the decimal points, you are sure about it. That's why those zeros are counted. I hope this is clear. Yep, that's how it is. Only when it comes in between, it is significant, and only when it comes after the decimal, then it is significant. The powers of 10, etc. are not to be counted. Okay, that's the simple way of remembering significant figures. Let's see how many of you can do this. Count the number of significant digits in this one. Count the number of significant digits in 3.00 meters. Come on. Beautiful. Ravindra, we are going to have Menti. Guys, yes, all my warriors, listen to me carefully. Next week, there is going to be a Menti on whatever we have learned throughout the sessions, right from the bridge course and units and dimensions, and I want to see who is going to ace it. I'm going to see that next week. Yep, come on, think. Yes, how many significant digits are there? 1, 2, 3, 4. Only this 0 is not to be counted. Yes, this 0 is not to be counted. So only 4 significant digits are there. Only 4 are there. Here, all of them are counted. So 3. That's the answer. Beautiful, guys. Beautiful. Yep. Bye-bye, Nancy. Take care. Yes. Okay. Understood. Looks like everybody has got it. Yes. These are not 5. This 0 is not counted because it's not after the decimal. Understand that. It's just a number. No decimals over there. So don't count that 0. These zeros are after the decimal. That's why it has to be counted. So that's the rule. Beautiful. Now let's do some operations on these significant numbers. Are you guys enjoying the lecture? And if you guys are enjoying the lecture, please hit the like button out there. Beautiful, guys. You're answering really cool. Okay, Manohar Boseti says old haircut is good. Okay, guys. Those of you say old haircut is good, put old in the chat box. Those of you like the new haircut, put new in the chat box. And based on that, maybe I'll change my hair. 0 in 780 is not counted, Jayavant edits, because you can write 780 as 78 into 10 to the power 1 or 7.8 into 10 to the power 2. So it doesn't matter. That's the reason. Okay. Very good. Enjoying, says Akriti, Yalini, Aishwarya, Sriram, Sashmita. Very good. Very good. Yes. New, says Shreyas Sir, says old. Harsha says no. Oh my God. Harsha says I should go off complete bald. Is it like Harsh Sir? Yeah, I just saw a meme on Harsh Sir. Somebody has made a meme on Harsh Priyam Sir. Okay, somebody, yeah, okay, old and new, old and new. Oh my God. looks like the new wins, by the way. Okay, looks like the new wins, but some of you are saying old also. Okay, I will probably keep oscillating between the two. Okay, no coloring, says Shyam Kumar. Oh my God, Shyam Color does not like us. Shyam Kumar, you can do one thing. You can watch the videos in black and white. That will be fun. Yeah, please watch the videos in black and white. Okay, chalo. Let's see some operations out there. Okay, let's see some operations on the significant figures out here. Whenever you add two numbers and they have different significant digits, then the final answer should be rounded off to the least significant digits. Whenever you have two or more numbers and you add, subtract, or even multiply and divide, doesn't matter. Whatever operation you do, then the final answer must come in the least number of the significant digits. So that's why rounding off is important. I'll give you an example. Okay, just look at this. Just look at this. 2.3, okay, 2.3 plus, okay, 5.11, okay, 5.11. What will be the final answer if you just have to do it? Okay, if you just had to do it, 1 plus 0, okay, 1 plus 0 is 1, correct? 3 plus 1 is nothing but 4, and that point comes 2 plus 5 is 7. But the final result, you need to check very carefully. How many significant digits does this number have? This has only 2. How many significant digits this number has? It has number 3. So you have to bring it down to only 2 digits. You have to bring it down to only 2 digits. Yes. So you have to round it off. That's why I told you the rules of rounding off at the start of the session. So 7.41, when you bring it down to 2 digits, it will become 7.4. And that is the final correct answer. This is the correct answer. Understood? Is that clear, everyone? This is how you need to do it. Let's see whether you can solve the problems now. Oops, I don't want to save it. Oops, cancel. Okay, let me just give you one more example. 8.00, okay, 8.00 multiplied by, very simple multiplication, 2.0000. Let's see who can write the final answer correctly in the chat box. Let's see who can write the correct answer in the chat box. 8.00 multiplied by 2.0000. Come on guys, let's see who can write it correctly in the chat box. Come on, multiplication, division, all of them have the same rule. Write the least number of significant digits. 8 twos are how many, guys? What is 8 twos are? 16. Come on. 16. Okay. 16. But count the number of significant digits. This has 1, 2, 3. This has 3 significant digits. Correct? This has 1, 2, 3, 4, 5. This has 5 significant digits. Who is less? 3. So final should contain only 3 significant digits. So 16.0. That's the answer. Not 00. Be careful. 16.0 is the answer. A lot of people make the mistake. Not the same decimals. Same significant digits. Be careful. Is that now clear? Understood? Everybody understanding this? How significant digits work? Yes. Be careful. Be careful. Yes. Oh, I hope if everybody has understood this, then we'll go ahead. Yes. Now, just remember one thing, guys. Just remember one thing. Okay. In case of multiplication, okay, in case of multiplication and division, you talk more about, the significant figures. But in case of addition, subtraction, the only small difference is this line out here. Decimal places. That's the small difference that is there. See, in a multiplication and division, you always looked at the significant figures, not the decimal points. But remember, in case of addition and subtraction, it's always about the decimal points that you should be worried about. So, for example, if again, let me say it is 7.20 and if it is, 8 or maybe, I don't know, something like 1.1, okay, then always, like I have shown you before, always look at the decimal points. This has 2 decimal points, this has 1 decimal point. Always go with the least decimal point. So if you are adding it, so this will be 3, this will be 8, okay? So the least decimal point, this has the least decimal point, so always put the least decimal point out there. Keep this in mind. Keep this in mind. So be careful about addition, subtraction, and remember the difference between that and multiplication and division. Okay, let's see 2 problems on this. Let's see how many of you can add these 3 numbers to accurate decimals. Find the result in current significant figures. 12.52 plus 349.0 plus 8.24. Let's see how many of you can do this. Come on, let's see how many of you can do this. Thank you, Sukruti, so much. Hi, Deepika, welcome aboard. Come on, all my warriors, start doing this. Let's see how many of you can add this to the least, to the correct decimal digits. Okay, come on. Come on, think about it. Remember, I'll give you a hint. Whenever it is addition and subtraction, it's always about decimal digits. Whenever it is about multiplication, that time it is about multiplication and division. Keep this in mind. Okay. Thank you, Sakshi. Thank you, Bhavya, so much. Okay, hi Yash, come on, join in. Okay, some of you are saying 369.7, some of you are saying 369, some of you are saying 369.8. Well, Monkey D. Luffy says 370. Okay, lot of you are wrong. Come on, guys, buckle up, count the decimal digits. Be careful. Yes, be careful with the decimal digits out there. Okay, so guys, count the decimal digits. Think about it. This addition, what are you going to get? 12.52 plus 349. Come on, guys, 12.52 plus 349 plus 8.24. What are you going to get? Come on, answer. What are you going to get? Exactly value. What are you going to get? You are going to get 369 point, how much? 52 plus 24, come on, 76, right? Yes, you are going to get 76, but this is not the final answer. Be careful. Here there are 2 digits, here there is 1 decimal digit, here there are 2 decimal digits, so you have to round it off to 1 decimal digit, and that's why the answer will be 369.8. 369.8. Yes, that's the correct answer. No, don't round it off to 370. Be careful. No, it's not 369. Be careful, guys. It is 369. 1 decimal digit here, 2 over here, 2 over here. The least number of decimal digits. Keep that in mind. Yes, I hope this is clear. Yes, auction sold. Beautiful. Okay, let's get going to the next question. Coming up on your screen. Get ready, guys. Oh, I should show the answer, my bad. Okay, yeah. So the dimensions of a wooden block are given 20 meters by 15 meters, 20 by 15. Count the number of significant figures in the final area. Count it. Come on, think. Careful, be careful, guys, be careful. Yes, in decimal we see only decimal part. Yes, Ritu. For addition, subtraction, remember it. I just showed you the rule. For addition, subtraction, check decimal. Only for multiplication, division, check significant figures. That's the difference. Okay, come on, be careful. Yes, what will be the final answer? 20 into 15, guys. If somebody had to just multiply 20 into 15, what will be the answer? It will be 300. But you cannot leave the answer like that. How many significant digits are there over here in 20? In 20, there is only 1 significant digit. In 15, there are 2 significant digits. So the least significant digit is 1. So final answer should have only 1 significant digit. That means 3 into 10 to the power 2 meters square. That's the answer. So there is only 1 significant digit in the final answer. Beautiful. Yes, Sri, if you want to revise this topic, definitely you can watch. Understand. Yes. Beautiful. Yes. No, Nidhi, these are not counted. These does not have 3 significant figures. These zeros after anything are not to be counted unless it is after a decimal. Understand that. I just gave the rule. So these zeros are not significant because you can always write 300 as 3 into 10 to the power 2. So there is only 1 significant digit. Understand that. Yep. So that's how this works. 3 into 10 to the power 2. I hope you guys are enjoying and I hope you have learned a lot. Now let's go to errors. Let's talk about errors. But before we go to errors, let me tell, a lot of students have a lot of doubts and you want a lot of questions to be asked and you want your doubts to be cleared. If you want your doubts to be cleared, one way is, you post all your doubts in the comment section below, and whenever I get time, definitely I'll reply to all of you. But I'm pretty sure you want more than that. You want to ask some questions, you want to send some screenshots, you want to ask whether this method is correct, you want to get some hint for solving a question, then we have this facility inside the Vedantu app. So when you use the Vedantu app, there is this facility where you can take a picture, send your doubts, chat with our doubt expert, get your doubts resolved, you can send solutions, ask for mistakes, and all these doubts get solved from morning till the night. All this is unlimited, yes, as long as you are in the pro subscription. So if you are in the pro subscription, do not forget to use this doubt facility out there. Now let's go to errors. Aaj menti nahi hoga, Ravindra, we are going to have menti next time. Yep. Okay, let's get going. Guba Nitin, if you are not able to find Zero to Hero playlist, please put it up in the comment section. I will ping you the link. Okay, let's get going. Thank you, Sakshi, so much. Okay, let's get going. Let's get going. Errors. An error is nothing but a mistake of some kind. How many of you think you don't have any kind of errors in you? मेरे में कुछ नहीं है, मतलब there is nothing wrong in me. How many of you think that? I am errorless, I am flawless, I am not having anything, I am perfect. Is there anybody out here? Yeah, come on. Thank you, Harshini. Glad you are loving it, bacha. See you more often. Ravindra, like I said, no menti now. Next week we'll have menti. Electricity, Shivani, we are going to have it next week in the Pathfinder series. Nobody out here? Okay, come on, not me. Okay, Samuel says some 5 hearts. Looks like he's just smiling. Okay, nobody. I am an error myself, says Monkey D. Laffy. Okay, not me, says Smita. No. Akrita says, oh, she is errorless, she is flawless. Okay. Shreyas Kapri says, I am full of errors. मैं खुद एक गलती हूँ. Okay, so nobody is perfect. So even a reading, a measurement can't be perfect. It's wrong. It's not right on our part to expect any reading that you measure. Let's say you're measuring current, you're measuring voltage, you're measuring your height, you're measuring your weight, you're measuring anything. Nothing will come with perfect accuracy. There will be some degree of error. Now there are different kinds of error that can be introduced. Example, this is a very beautiful chart which will help you understand. Gross errors. Now what the hell is gross errors? Gross errors are basically these human mistakes, random things that you do. These are basically because you're not holding the instrument correctly, you're not holding that apparatus correctly, you are doing some mistake on your own. So these are basically called gross errors. Improper setup, you are doing some mischief, or sometimes it can happen that somebody is taking a reading 23, and that person is reading from far away and he sees that 3 as 8. It happens even in the question paper. You see that 3 and you think that it is 8 from far away and you write 8. That is a stupid gross error. I hope you understand this. So these are basically gross errors. Okay, beautiful. I hope this is clear. Now, the next type is systematic errors, and there are 3 types of systematic errors. One is instrumental errors. We are going to talk more about it, like least count error or zero error. We are going to talk more about it now. Don't worry. Observational error. An example of observational error is parallax. Parallax. Just imagine this. If there are numbers like 1, okay, 2, okay, 3, and then 4, and then 5 over here, and this was my needle. This was my needle. Okay, this was my needle. Now the needle is here at 2. But when I see from here, then I find that the needle is in front of 3. I find that the needle is in front of 3. But I see from here, then I see the needle is in front of 1. But I see from here, then I find that the needle is in front of 2. It happens in case of your wall clock, because there is some distance between the scale or the dial behind and the pointer out there. So from different angles, you find the reading to be different. That is called as parallax error. I hope this is clear. No problem, Padmalam. G, no problem. Yes, join in and watch the replay of whatever part you missed. Yes, is that clear, everyone? Is that clear? Okay, last one, environmental errors. Temperature changes, pressure changes, humidity comes, some corrosion happens. Because of environment, you know, the steel scale might bend. Maybe there is some kind of fluctuation in the resistance because of pressure change, humidity change, environmental changes. Those are called environmental errors. Last one is random errors. Now these are perfectly random. Like, it happens. Has it happened with you? Let me know. It happens with me many times. You check your weight on a digital scale. You stand on it and then you see, oh, my weight is 70. And then you come out and again check it once. And then you see, then it shows 70.1. And then you're like, oh, what the hell? And then you climb back on it again and then it shows 69.9. It's random. I don't know why it happens. It's random. That's why it's called as random errors. Every time you take a reading or a different person comes and takes the reading, it might be different for different weird reasons, weirdest of the weird reasons. That's why it is called as a random error. I hope this is clear. Yep. Corona error. Corona is itself an error, Akriti. I mean, what else can I say? Yeah. Do you think board exams will happen? No, Richa. Board exams will not happen for 10th. That's it. You are done. Now you are in 11th. You are my bachchas. How many of you are still sentimental of 10th, guys? Please get over it. If you are going to be so sentimental about 10th, then understand you cannot study and work for JEE. You need to move on. You are now in 11th standard. I know you love your teachers. I know you miss your school. I know you might miss your batchmates of 10th standard. But guys, please buckle up. You are now in 11th standard. Are you in 11th standard? Yes or no? Let me know. Yep. Okay, cool. Now let's do some questions. Errors due to instrument. So let's talk about errors due to instrument. The first thing, come on guys, let's do this. Yes, there are a lot of questions that are going to come up. Least count error. That's the smallest number that the instrument can count. My watch over here, what do you think is the smallest number that my watch can count? Come on guys. What is the smallest number that my watch can count? Let me know in the chat box. What do you think is the smallest number in the, smallest number my watch can count? Come on, think about it. What's the smallest number my watch can count? Come on. Quickly. Let me know in the chat box. Waiting for your answers. Come on, guys. Come on. Let me know. What is the smallest number? And what do you think the smallest? Yes, Abhinav says 1 second. No, Monkey D. Luffy, my watch is not that accurate. It is 1 second. Yes, correct. So, can I ever say, let's say somebody is running. I don't know who is running. Okay, let's see some of the fans out here. Okay, Vijay Kumar is running. This is Vijay Kumar, guys. Vijay Kumar runs from this point to this point. 100 meters he runs. 100 meters. And he runs in 9.835 seconds. Can I tell this using my watch? Is it possible? Isn't it funny that my watch can, it has a maximum accuracy of 1 second, and by some genius technique, I'm telling you, oh, Vijay Kumar has run 100 meters in 9.835 seconds. How the hell did I talk about the decimal points when my least count was 1 second? My least count itself was 1 second. So understand that that's the least count of this watch. Similarly, the scale over here, I cannot measure, no matter what I do in my life, I cannot measure more than 1 millimeter. The scale, the error of the scale is 1 millimeter. So it's illegal if somebody writes the length of that object using this scale. Using something else, maybe yes, but using this scale, if somebody writes the length is 2.3 millimeters, he is wrong. It's illegal. It's punishable. Understand that. But somebody can write 2 millimeters. Yes, this is acceptable. So that's the least count, guys. I hope this is clear. I hope this is clear. Beautiful. Everybody is understanding this. Excellent. So that's the least count error. That's the smallest value you can measure. So understand any length. Oops. So the length of that object can be written down as, I don't know, 70 millimeters. But there is always an uncertainty of 1 millimeter. This is your uncertainty. You do not know. You're not sure of that plus and minus 1 millimeter. Same way, using my watch, I can say the time is, I don't know, 10 seconds, but always an uncertainty of plus minus 1 second. I hope this is clear. Is this clear? No, Sriram Reddy Narana is not at all good for JEE. Nope, don't. Yep. Okay, I hope this is clear. Beautiful. Everybody understanding it? Shall we go ahead? Shall we go ahead? Let me know in the chat box. Next is zero error. Zero error. Have you seen a shopkeeper always sets or resets his weighing machine to 0 before putting anything? I mean, it will be again illegal for the shopkeeper to actually have some value out there before selling something and before putting that object on that pan. Isn't that right? Isn't that right? Think about it. No, Richa, random errors can be rectified till a small degree but not beyond a point. Yes, you cannot have a non-zero number showing even before you put something. That is called as zero error. As simple as that. When you do not have anything, then the instrument should show 0. When you have something, then the instrument shows some value. But what if the instrument already shows, let's say, who is this person? Who is Samuel John? So Samuel John, this is Samuel John, guys. So this is Samuel John out here. This is Samuel John. Okay, he's our warrior and he's standing. Now before he stands, it shows, let's say 1 kg. Before he stands. And after he stands, it shows 43 kg. So what do you think is Samuel John's actual weight? What do you think is Samuel John's actual weight? Come on guys, let me know in the chat box. Okay, what do you think is Samuel John's actual weight? Come on, let me know. Yep, let me know. Mala Mohan, please let me know all your doubts and queries in the chat box later on. I won't be answering any doubts while the session is going on, okay? Yes, come on, think. 42 kg or 43 or 44? Come on, let me know. 42, 43, 44. Yes, it is 42 kg. He is 42 kg because you have accounted for that 1 kg. It was already showing 1 kg. So, out of 43, 1 kg is in excess. So, hence his actual weight is 42 kg. Beautiful. Beautiful. Excellent. Now, let's see this question, beautiful question. Let's see whether you can answer this very quickly. Imagine the weight of Samuel John was measured by 4 different people. 4 different warriors out here have measured these values. So look at that, 40 kg, 39 kg, 38 kg, 41 kg. What do you think is the average weight of this person? Come on guys, let me know. Come on, think about it. Oh my God, Richa Roy says students look like vacuum diodes. Good one, Richa. Okay. Come on. Only Samuel knows, says Abhishek Mitran. Good one. Hello, Didi Maruti. Wow, nice name. Good evening, everyone. Come on, those of you who are joined in late, it's okay. Watch the lecture live. The remaining part, you can watch the replay later on. Okay, come on. What do you think is the average weight? 40, 39, 38, 41. Come on, do the average. Come on, quickly. Dun, dun, dun. Do the average quickly. Waiting for your answer. Okay, Chinmay Pense says 39.5. Mala Mohan says 39.5. Sai Telugu says 39.5. Thank you, Sakshi, for being my biggest fan in the world. Thank you so much. Okay, beautiful. Yes, the answer is 39.5 kg and everybody knows how to take the average. So average is nothing but, add all these numbers. 40 plus 39 plus 38 plus 41 plus nothing. Okay, divided by number of readings. 1, 2, 3, 4. So that's it. That's going to give you 39.5 kg. Beautiful. Now the next set of questions. I'm talking about, I have written weight. My bad. This should have been mass. It's understood. So I'm okay. Okay, cool. So the mass is 39.5 kg. Okay, next question. What do you think is the error in the first, second, third and the fourth reading? Same data, but what do you think is the error? Remember, the average value was 39.5. Average was 39.5. So from the average, how much did I deviate? How much did each person deviate? Think about it. The 40 kg, that first person has deviated by 0.5 kg. Do you see that? The first person has deviated by 0.5 kg. The second person who measured 39 kg, he also deviated by 0.5 kg. Plus or minus does not matter, but he deviated from the average by a 0.5 kg margin. And this guy, he deviated by 1.5 kg, correct? And the 41 kg guy, oh, look at the deviation. It is also 1.5 kg. So these are the deviations. These are the errors from the average value. Each person had this error. This is the most likely reading. This is the most likely mass of this person. From this most likely average value, these are your deviations. I hope this is clear. I hope this is clear. Is that understood? Everybody, have they understood? Beautiful, beautiful, beautiful. Yes. Now, can you guess what? Samuel is sad. I don't know why you're monkey D. Luffy. Okay, so if this is understood, everybody clearo? Let me know by writing clearo in the chat box. Clearo? Yes, let me know in the chat box. No, Pratap, I'm interested only in the modulus, Pratap Patil. The modulus, the mod value, the absolute error, absolute deviation. I'm interested in that. Okay, beautiful. Now, let's say I ask you, what is the average absolute error? What is the average of the absolute errors? These were the absolute errors. This was the error in the first reading. This was the error in the second, third and fourth. What do you think is the average of these errors? So the average of these errors will be 0.5 plus 0.5 plus 1.5 plus 1.5. The whole thing divided by 4. How much is it going to be? How much is it going to be? Think about it. Yes, think about it. Yes, it is going to be 1. Beautiful. Beautiful. Yes, it's going to be 1 kg. Yes, that's the answer. You can see that. The average deviation, average absolute error, modulus of that error, the average is going to be 1 kg. Great. Now if you have understood this, no, it's not 2 Prince Patwa, no, it's not 2, it's 1 kg bacha. You can calculate 0.5 plus 0.5 plus 1.5 plus 1.5, whole thing divided by 4 is going to be 1. Be careful. Now, if I ask you what is the, not the weight, actually this should be mass. Okay, what should be the mass of that person? Then, here is what you will do. We just calculated the average value is 39.5. Average value is 39.5 kg. And the average error is 1 kg. Hence, the mass of that person is written down as 39.5 plus or minus 1 kg. That's how you write it down. Yes, beautiful, Abhinav Chaurasia. Excellent. Okay, Samuel John is not sad. Okay, let's put a smile on his face. Okay, is that a smile? Yeah. Okay, so that's Samuel John smiling, I guess. Okay. Okay. Cool. Understood, everyone? So that's how this works. Okay, that's how this works. So what have we learned? Whenever you have multiple values, when mass be negative, no Malamon, mass will not be negative. Whenever you have multiple values, you can find the average value, you can find the error in the value, you can find the average of that error, and finally you can give the answer. So these are the steps. So any reading can always be written down as the most probable value plus or minus some error. There is always some degree of uncertainty, plus or minus error. So your answer will be somewhere in between those two extremes, plus value and the negative value. So somewhere in between you're going to have your measured value. This is the most probable value. So like you can see in the previous thing, this was the most probable value. This is that uncertainty or that error in that measurement. Okay. Now whenever you have multiple readings, what will you do? Like you can see, whenever you have multiple readings, always take the average value, then take the error So subtract the value from the average, you will get the error. It is represented by a symbol delta. What is the symbol delta? It's the error in that value. Yes, so that's the error in that value, and you can take the average of that error. You can take the average of that error, like we just figured out it to be 1 kg. That's called as the average error in the reading. Now, two important terms. Relative error. Relative error means how much is your error upon how much is your average value. Error upon average value, that is called as relative error, and when you multiply it by 100, it becomes percentage error. Example, I tell Samuel John's mass is 50 kg plus or minus 1 kg. Example, 50 kg plus or minus 1 kg. That means the relative error is the uncertainty upon the most probable value or the average value, which is 50. That's the relative error, the fraction of it. I hope everybody has understood this. So basically the fractional error or the relative error is nothing but 0.02. Yes, that's the meaning of that. And if I ask you percentage error means this number multiplied by 100. So it is basically 2% error is there. Yes, there is a 2% error because out of 50 kg, you are not sure of that 1 kg. So that is a 2% error in the reading. As simple as that. Yes, is that clear? Oh, Akriti said that you are leaving. No problem. Sakshi, my timings my days can change. So that's why I say please join the Telegram channel so that you can get the actual dates out there. Weekly basis we can change. Yes, so that's how it is. Okay, the last part of errors. Get ready, let's do this. The last part of errors, and then you are going to become masters just because you have attended my complete class today. Okay, whenever you add things, whenever you add or subtract things, then you need to also account for the errors they carry with themselves. So remember this. Whenever you add certain things or subtract certain things, their errors also get added. I'll explain this to you in a beautiful example. Let's say this bag, okay, this bag has some rice. How much rice it has? It has, let's say, 7 kg plus or minus 1 kg. I don't know. I'm not sure of that 1 kg, 7 plus or minus 1 kg. Then I have one more bag of rice and it has maybe 3 kg plus or minus 2 kg. That's insane. I mean, I know it is 3 kg plus or minus 2 kg. This is just an example. Okay. So, what is the total rice that I can have? Think about it. Okay. So, think about the most extreme values. 7 plus 1. What's the highest amount of rice you can have? You can have 8 kg of rice. And here you can have 5 kg of rice. Maybe you have 8 kg of rice from here and 5 kg of rice from here. So totally you might have 13 kg of rice. Correct? That's one possibility. Similarly, the other extreme case that is possible is maybe you have only 6 kg of rice. Maybe you just have 6 kg of rice and maybe 3 minus 2 is 1 kg. 1 kg of rice. That's the lowest possible values. So 6 plus 1 is nothing but 7. So you might have either 7 kg, that's the least value. Highest value is 13 kg. So anywhere in between. So think about it. Actually what you have is 7 plus 3, which is 10, plus or minus 1 plus 2. 1 plus 2 is 3. So 10 plus or minus 3 kg. 10 plus or minus 3 kg. That's what you have. Is that clear? Everybody understanding this? Beautiful? Okay. Now imagine this. If I have 10 plus or minus 2 kg, if I have 10 plus or minus 2 kg of rice and I take away, how much do I take away? I take away 3 plus or minus 1 kg of rice. Then how much is left? So I have to subtract. I had this much rice, I take away this much kgs of rice, how much is left? That's the question. That's the question. So think, what's the maximum value? What's the maximum value of rice that can be left? Maybe I had 12 kg of rice, because 10 plus 2 is 12, and I took away only 2 kg from it. That's the maximum amount which can be left. When I have lot of rice and I take away only a small amount, so that means I might have 10 kg left. That's one possibility. Or maybe I had very little rice, which is 8 kg. 10 minus 2 is 8, but I took away 4 kg from it. 3 plus 1 is 4. That's when very little rice will be left, and that is nothing but 4. So do you see, the reading can be anywhere between 10 and 4, the left amount. So can you see what is the final answer? 10 minus 3, 7. 10 minus 3, 7, but don't subtract this. 2 minus 1, nah, 2 plus 1, so 7 plus minus 3. Understand that, and you can see that. 7 plus 3, 10. 7 minus 3, 4. Yes, so whenever there is a subtraction, do not subtract the errors, add the errors. That's the catch. Lot of people make that mistake. Whenever you have to subtract, they subtract the errors. Nah, do not do that. Subtraction or addition, always add the errors. Remember that. Is that now clear? Everybody understanding this? Everybody understanding this? Are all my warriors, are all my minions, are all my warriors clear about this? Let me know in the chat box. Yep. Very good. Is this in the syllabus of JEE? Yes, Chinmay, or else why would I teach? All these kind of questions are going to come. Let's see how many of you can answer this question. The mass of a stone is this much and another stone is this much. What is the total mass? Come on. Yes, it is NCERT. Whatever is there is an NCERT is also there in JEE Mains syllabus. Remember that. Do not forget it. Come on, all my warriors, which option is correct? Quickly, quickly, quickly. Today's lecture is going to be extended by more 5-10 minutes, and that's it. More 10 minutes, guys. Come on, come on, come on, come on. Quickly, quickly, quickly answer the question. The mass of this stone is this much. Another stone is this much. What is the total mass of the stone? Come on, total mass. Yep, come on, think carefully. Okay, thank you. Say through OP. He says, okay, a lot of you are saying B. Beautiful. That's the correct answer. 15 plus 20. 15 plus 20, 35. 0.3 plus 0.3. Yes, 0.6, correct. 0.3 plus 0.3 is 0.6. Yes, that's the correct answer. Beautiful. Next question coming up. Initial reading is this much, 18 plus minus 0.5. Final reading is this much. What is the rise in the temperature? Initial reading is given, final reading is given. What is the rise in the temperature? Come on, think about it. Let's see how many of you can give the correct answer. Beautiful. Come on. All my warriors have given the correct answer. Excellent. Come on, quickly, quickly, quickly. Initial reading is given, final reading is given. What's the final change? Sorry, what's the change in the temperature? Come on, all my warriors. Some of you are saying A, some of you are saying D. No, B, I guess. Okay, A or B. Come on, come on, come on, come on. What is the change? Subtraction. Hint is you have to subtract. So, final is 40. Initial is 18. 40 minus 18. Come on, how much is it? 22. Next up, do not subtract 0.5 and 0.3. That would be stupidity. Add it. Remember I told you whether it is subtraction or addition, always add. So 0.3 plus 0.5 is 0.8. Hence the answer is 0.8. Yes, option A. Beautiful. Beautiful. You should be really happy about this. Beautiful. Excellent. Now, you might be like, sir, what about multiplication, division, etc.? Simple rule. Look at this. This rule will help you for everything. Oh my God, this was not supposed to be. Just 1 second, guys. Yep. Oops. This was not supposed to be plus. I'm not sure why this was mentioned as plus. This is multiplication. Okay, this was multiplication. I'm just changing it just so that we have the correct things out there. Okay. Okay, cool. So if Z is something into something into something, then the final result has this much error. Now this is the formula. Now I'll tell you what this is. I'll tell you what this is. For now, just remember this formula. I'll tell you what it means. Let's take an example of multiplication. Simple example of multiplication, like displacement is velocity into time. Okay, displacement is velocity into time. And what is given? Velocity, okay, velocity is 100 plus or minus 1 meter per second. And let's say time is given to be, example, 10 plus or minus 1 second. Now the question is, find the value of displacement. Find the value of displacement. Now this is what you need to do. S is V into T. Something is something into something. Check the powers. What are the powers of velocity and time? Okay, now look at this. Check out the powers of each term out here. What is the power? 1. What is the times power? 1. Okay, so those are the powers. Now use this formula. Delta Z by Z. That means delta S by S. Delta S by S is power of the first variable. What is the power of the first variable? 1. Okay, 1 into the error, relative error in the first variable. What is the first variable? Velocity. So delta V by V. Next, second power. What is that second power? It is also 1 into relative error of the second quantity, which is delta T by T. This is how you should use this formula. Power into relative error plus power into relative error. There is a small thing over here. This should have been modulus. It's always the mod value of the powers. Even if the power is negative, I'll come to that in a bit, but it should always be the modulus value. Now observe this. What is delta V by V? Error in velocity 1 divided by 100 plus, I hope this is clear, plus what is delta T? Delta T is 1 and time, that is nothing but 10. So guys, what is this going to be? 0.01 plus 0.1, which is 0.11. Is that correct? So that is the relative error in displacement. But you can also further simplify it. How? What is delta S? I don't know. I'll just keep it like that. But I know the value of S. I know the value of S. S will be velocity into time. What is velocity? 100. What is time? 10. So this S is nothing but 100 into T. 100 into time. I hope this is clear. I hope this is clear. Everybody understanding this? So guys, what we have done is, when we found out this value of S, just take this V and just take this T and just multiply them. So that is 100 into 10. So that's why this will be delta S by nothing but 1000. Delta S by 1000 is nothing but whatever is remaining over here. So if you want to find delta S, 1000 into 0.11. Come on, how much is 1000 into 0.11? Come on, all my warriors. Come on, I'm reading all your chats out there. Didi Maruti, you can replay back the session. Please replay back the session. Thank you, Sakshi. So how much is it? Yes, 110. Beautiful. 110. Yes, that's the answer. Hence, the final displacement will be, what was velocity into time? What did we get? 100 into 10. We got it as 1000 plus or minus 110 meters. That is the final answer. That is the final answer. Beautiful. That's how you need to solve it. That's all that is there. Okay. Now, sometimes you might have division also. Example, velocity is displacement by time. Now observe this carefully so that you understand everything else. Observe this carefully. In case you did not understand the previous part, you will understand it now. Or I can take something else also. Doesn't matter, guys. Okay, I'm just giving an example. Velocity is displacement by time. Let's say displacement is 100 plus or minus 1 meter. Let's say time is, 10 plus or minus 1 second. Example. So then, first thing, what will be the actual value of velocity? Velocity will be 100 divided by 10, which is nothing but 10 meters per second. But I want, what is the error in the velocity? So again, use this result. How will you use this result? Observe this. Velocity is actually displacement raised to 1. s raised to 1 into t raised to minus 1. There is a negative power of t. Did you see that? There is a negative power of t because t is downstairs. So always write it in this form, this beautiful form. Now use this formula. Now if you use that formula, what will you get? Delta v by v is equal to the power. Oops, shut up my Siri. Okay, so what is the power of s? It's 1 into delta s by s. Okay, plus always take the modulus. What did I say? Always take the modulus. What is the modulus of minus 1? What is the modulus of minus 1, guys? The modulus of minus 1 is 1 only. Remember, always take the modulus into delta t by t. Keep this in mind. Now just substitute everything that you know. What is the value of v? V value is 10. What is the value of delta s by s? 1 by 100. Okay, 1 by 100 plus delta t by t, that is 1 by 10. What will this be? 0.01 plus 0.1. So that is going to give me delta v by 10 is going to give me how much? 0.11. From this, what is the value of delta v that I'm going to get? I'm going to get delta v as 1.1. Yes, I'm going to get delta v as 1.1. I hope this is clear. So final velocity will be, what is the final velocity I'm going to get? It will be 10 plus or minus 1.1 meter per second. That's the answer. Where did I get this 10 from? Here. Where did I get this 1.1 from? Here. So 10 plus or minus 1.1. Understood? Understood? Oh? Clear? Oh? Beautiful. Oops, I don't know why this answer was given, but okay. Yeah, will we be solving NTA questions? Yes, we'll be solving NTA questions. So I'll do one thing. Just solve this as homework. I'll do another question in front of you. Oh my god, looks like the question slide is after the answer slide for some reason. It's okay. I'll just make you solve a question over here so that you get to know how this question was solved. You can take it up as homework also. Okay. See guys, what is the error in the measurement, okay, of the volume if the error in the radius is 2%? What is the error in the volume if the error in the radius is 2%? Let's solve this. Very simple. What is the volume of a sphere? What is the volume of a sphere? 4 by 3 pi r cube. Correct? The volume of a sphere is 4 by 3 pi r cube. Now what did I give you? That formula. Recollect that formula. When something is something into something into something, always take that relative error. Relative error. First of all, these are constants. This is a constant. So remember one thing, it doesn't matter. It doesn't matter what the constant is. So forget that there is a constant. It really doesn't matter in that formula also. Check the power of the r. What is the power of r, guys? 3. And then write down delta r by r. Relative error. Remember that final relative error is power into each term. If there are more terms, I would have written down more terms, but there are no more terms over here. Correct. Now just multiply by 100 on both sides. So delta v by v into 100 is 3 into delta r by r into 100. Now the reason why I'm writing it like this, look at that. The error in the measurement of the radius is 2%. That means this much is 2%. Delta r by r into 100 is 2%. So 2% into 3%, sorry, 2% into 3, how much is it? 6%. That is the answer. Yes, so this is the answer. Beautiful. Beautiful. That is the answer. Yes, 6%. Understood how to solve these kind of questions? So whenever you have multiplication, division or any kind of powers, always write it as something into something into something, each term raised to those powers, and use that formula which I just gave you. You will always get it. I hope you are now confident about this. Yes, this is 6%. I have kept 3 to 4 questions for you for homework. Drop the answers in the comment box below. Round this off to 3 significant digits. Second question, mass of this body is this much. Count the number of significant figures in this. That's your second question. And the third question, the radius is this much. Find the volume in the correct significant figures. That's your third question. And the last question, length and breadth are given. what is the percentage error in the area? These are your 4 questions. These are the 4 questions for you guys. And remember, the pro subscription is there, which is starting again on 24th of May. So if you want to be one of the toppers like this, remember the next course is starting on 24th of May. And if you want to be the one who makes it up to this board, who wants to be one of these numbers, who wants to be the JEE Mains topper in 2023, guys, start the preparation right away. The link for joining our pro subscription is there in the description box below. Check it out. There is English batch, Hindi batch separate with lots of micro courses, assignments, test series every now and then. I feel you should not miss that opportunity. Remember, there is a light version which has everything. There is a classic version which has everything that the light version has, like tests, assignments, live classes, replays, micro courses, everything. Apart from that, you also get doubt solving. Okay, and if you want personal mentorship as well, then you go for the plus version. That's the only difference. Otherwise, the batches are etc. are same. And remember, you can avail 10% off by using the coupon code SHHPRO. If you want to know more about this, please ping me on my Instagram handle, that's Shreyas_Vedantu. Okay, out there, and I will definitely help you out. Thank you guys very much. Good night. Bye bye. Hasta la vista. Take care. See you again tomorrow for a special yoga session, relax your mind session with me and Ashrita, who is the founder of a yoga school, and you will be meeting her live tomorrow at 7:30. Bye bye. Take care. Signing off. This was Shreyas here, your master teacher.